And now let's go over a concept example. So let's consider a real-life example of a neural network applied in facial recognition technology. This technology is widely used in various security systems, smartphones, and social media platforms for tagging friends in photos, and even animal recognition at the same time. And at the heart of facial recognition is a neural network that has been trained to identify and differentiate faces based on thousands of images. So, a neural network is trained on thousands of, I'm going to just put this in red just to give an example, images as an example. You can apply this to almost anything, and thousands, I mean, it really depends on your application for the most part, depending on how intense it is. But in the realm of deep learning and supervised learning, the conventional approach is typically more data, more GPUs to be able to actually have a higher means of accuracy. But that's just something on the side to put in some extra information. But the point is, in this example for facial recognition, the neural network has been trained on thousands of images. So we're just getting the basics through. So initially, and we all know for a fact that a neural network always has three parts to it. It always has the input layer, one or more hidden layers, and finally the output layer. And we all know that the input layer is where the data goes. There we go. One more hidden layers is where the training happens to recognize patterns in data. And finally, the output layer is the result after training. So initially, the input layer receives an image as an array of pixels. This hidden layer then processes these pixels to identify patterns, shapes, and features such as eyes, noses, and lips, and each layer captures increasingly complex details, from single edges at the lower layers to high-level features like facial structures in the deeper layers, altogether in the faces. And then this process is made through the network's weighted connections, because we always know that between this whole learning process and every single component of the neural network is comprised of neurons and goes through a learning process via activation functions and the weighted connections are adjusted during the training phase using a vast collection of labeled images. And finally, the output layer then produces a vector of values that uniquely identifies the face in the image. So after the result of the training, we're going to get a vector of values that uniquely identifies the face in the image. Values in the face of the image. And then overall, after the neural network has been trained, it would be comparing the results to a database of known faces to find a match. Then the neural network would compare results of the images to a database of known faces to find a match. The success of a facial recognition technology hinges on the neural network's ability to learn and generalize from the training data. So really the hidden layers are the most crucial part when actually understanding more in how the neural network operates in terms of the training phase, allowing it to accurately identify faces in a wide range of conditions, including different lightings, angles, and facial expressions. So overall, let me just clean this up. So in facial recognition technology, we know that the neural network is trained on thousands of images to be able to have the result. We know that there are 3 layers to a neural network: input, one or more hidden layers, and then finally the output. Output gives us a vector of values that uniquely identifies values in the face of an image, which is the subject of what we are looking for. And then the neural network would compare results to an image to images in a database, not two. And we also know and remember that the learning phase is made by neurons, and it's a continuous improvement via activation functions as well. And we also know that the output is also calculated and trained with backpropagation. And typically adjusting with gradient descent. And so let's move over to our first practice problem.